Sure. So welcome everyone to the industrial panel session today. We are talking about benchmarking in data center as is the topic of the workshop. And we're also trying to see a diverse perspective from both like people who are in the industry as well as academia. And we want to see how benchmarking is being done. What is the state of the art in benchmarking in data center, and also expanding a little bit on the clouds like Azure and AWS. So I am going to be co-moderating this session with Shahzeb, and please go to the next slide. Yep. So the way we're going to do it is we're going to just do a brief introduction about ourselves and then our respectable panelists. And then we have a set of 5 broad questions, and we're going to do that with the, get the perspective from each of those panelists on that. And if we have some time remaining, then we would also like to address some question and answers from the audience. And meanwhile, the audience can also post the questions to the Zoom chat. Next slide, please. So a little bit about myself. I recently graduated from Ohio State. I was with the MPI MVAPISH team with Professor Panda there. And then last year, I joined Microsoft as a researcher. So I'm working with this open source software or deep learning training library called DeepSpeed at Microsoft. And I would like to hand off to Shahzeb, and he can introduce himself.
Yes, so my name is Shazee Siddiki. I'm an HPC consultant at Lawrence Berkeley National Lab. So I'm part of the ECP project. I spend in the software deployment group. So we're responsible for like building and optimizing, kind of the scientific software using SPAC and just installing them on the DOE systems. Like Aurora that's coming out, and we also install on like Cori, Argon, and also on OLCF. Just a little bit about me. I'm involved in like several open source projects. So like we use SPAC for installing software. I've worked with Singularity and also EasyBuild, managing software stack. Installing and testing. Also creator of a testing framework called Build Test, and also L module, helping for like the facility to kind of do like system testing. And I work with mostly like the DevOps tool, like installing software. And I have a master's from KAUST and bachelor's from Penn State. And with that, I'd like to introduce our panelists for today. We have Verónica from Oakridge, Jithin from Microsoft, and Sreeram from NVIDIA. So yeah, Verónica, she has a BA from Reed College and MS from Florida State. She's part of the pre-production systems team as a group lead. And yeah, I'd like to give some time for Verónica to introduce herself. Are you there, Verónica?
Yes, thank you, Shahzeb and Ammar. So as Shahzeb mentioned, I hope you can hear me okay. I'm an HPC engineer in the Oakridge Leadership Computing Facility, and recently became group leader of the pre-production systems group. So a lot of what my group does, it's making sure that the user environment it's already maintained and sustained the necessary performance and stability that the system needs. So whenever we're doing upgrades, my team is in charge of installing the software, testing the software, and making sure that everything is still working correctly. And in addition, whenever we're deploying a new system, our group is responsible for coordinating a set of tests for acceptance testing and making sure that whenever we deploy the system, you don't find like any critical issues that will prevent workloads from functioning correctly, that we're able to get the performance that we need from the system that the contract specifies, and also that the system can stay up for continuously without major interruptions. So we do a lot of like functionality, performance, and stability testing before we actually hand it off to the users in the production side. And yeah, as Shahzeb mentioned, my background is in mathematics and physics, and I also have a master's in computational science. but I've been at Oakridge since 2014 or so.
Thank you. Next, I'd like to introduce Jithin Jose. He's from Microsoft, and his focus on co-design of software and hardware. And his research is in, high performance interconnects and protocols, for parallel programming and cloud computing. Before Microsoft, he was working on Intel and IBM, and he has a PhD from Ohio State. Jithin, would you like to introduce yourself?
Sure, thanks, Shahzeb. Hey, so I'm Jithin from Microsoft. At Microsoft, I work at the Azure HPC team, specifically the HPC platform team. So our main responsibility is to design the next generation HPC SKUs, gather the workload characteristics, and accordingly design the SKUs. Not just HPC, like HPC AI and visualization, and then finally making it available for the end user, right? So that's our team. So I lead the HPC SKU specifically, and focus a lot on the HPC software ecosystem, and conduct a lot of benchmarking activities for the different layers of software. As we all know, it's a for different variety of applications, it's a different set of stacks. Eventually it's all very similar, but the layers are entirely different. So we do a cross-layer approach, and making sure, starting from the bottom up, so from the system, we all go up all the way to the application to make sure the end-to-end application performance is all right, and we make it available for everyone. Thank you.
Thank you, Jithin. And last, I'd like to introduce Sreeram Potluri. He is from NVIDIA. He's a system software manager, and he's leading the GPU communication group. And he provides the network and runtime solutions. And he has a PhD from Ohio State. Sreeram, would you like to introduce yourself?
Sure. Thanks, Shahzeb, and thanks, Ammar, for inviting me over to the panel. So like Shahzeb mentioned, I lead the GPU communications group at NVIDIA. So we develop technologies like GPU Direct RDMA and GPU Direct async that enable efficient data movement between GPUs on a cluster. And also we develop several libraries that are kind of built on top of these technologies, right? Like Nickel, we contribute to OpenMPI, and we have a library called NVSHMAM that provides GPU-centric communication. So essentially, we try to provide both technologies and libraries that allows applications to kind of move bytes efficiently between GPUs in the cluster. And so we kind of engage regularly with teams at NVIDIA and elsewhere, like to kind of get best performance as they're running both micro benchmarks and applications on these systems. So basically benchmarking and tuning both our runtimes and understanding the system topologies and designing them is something that we do day in and day out. So yeah, happy to participate in this panel.
Thank you, Sreeram. And now with our next part of this session, what we'll do is we have a Q&A. So we'll have like a slide per question, and we'll give you guys the opportunity and feel free to speak about the question, and then we'll just go from there. And the audience, you'll feel free to just post your questions in the chat. So I'd like to give it off back to Ammar.
Hey, thanks, Shahzeb. Yeah, so the first one is actually my favorite question, and I want to ask that to the panelists and get some perspective. So what are some of those major benchmarks that we use today in the current data center and commercial cloud environments, like Azure, AWS, and others, for different workloads, including especially the machine learning and deep learning workloads, because they're upcoming. So I think, I don't know how we want to start, but maybe let's give Verónica the chance to respond to that one first, and then we can go to Sreeram and Jithin.
Sure, thank you. On the data center side at Oakridge, where we use a variety of tests, a lot of our procurements, especially for acceptance testing, already include benchmarks that are targeting the specific workloads that DOE has in mind. So for the Frontier, for example, the Coral 2 benchmark set of benchmarks is already available. And since the specific question was about machine learning, the last time around when we had the summit procurement, we didn't actually have a specific machine learning codes because it was still like an emerging, I know people were starting to use machine learning, but the summit procurement started a few years back because procurements happened 3+ years before we actually started having the machine on the floor. But for this time around, for Coral 2, we actually included several, they're mostly like micro benchmarks. So we have a machine learning and deep learning micro benchmark suite that was added to Coral 2 benchmarks. We also have a data science suite of benchmarks that includes a few of the packages that are commonly used on like PyTorch and things like that, that are heavily used on Summit now, but they weren't used so much when we had Titan. So it's an evolving set of benchmarks, but in general, not just in the machine learning space, the way we try to do our benchmark testing is to look at the workloads that are being run today. And then we look at the different programming models, the libraries being used, like the different algorithm motifs, and then we pick from our portfolio of tests. We try to come up with a few of the real world codes that we're using on the system that we can run to verify that in the next system, they will still be able to run, they're able to solve the same problems, and they're able to do it with the expected performance that in theory, it should be faster in the next system. So we sort of try to look for a perspective or realistic workloads. And now that we have some realistic workloads to pick from in the machine learning side, we're doing the same exercise by analyzing everything that people are running on Summit today and picking out a few sample cases that we can use to put in our production workload for Frontier.
Great. Thanks, Verónica. So you mentioned Coral 2 benchmarks. Are those benchmarks like open source, or are they just?
I can put the link in the chat if people are interested. And a lot of the codes is just basically we pick from a list. So you'll find things like QMC pack, LAMPS, NAMD, things like that, depending on whether it's Coral 1 or Coral 2. But they're just posted online. And yes, a lot of the benchmarks are open source, but most often, like for Summit, for example, IBM was responsible to grabbing the code for NAMD and then optimizing it for the new architecture. And those optimizations are the pieces that are not necessarily open source because not every company will upstream their changes, or even the project itself may not want those changes for their product. So it's a bit of an open, some of them are available openly, some of them are not. But if any of them are of interest, I'm happy to come back if anybody's interested and let you know if that actually upstream the changes that they made. But for the most part, the DOE science apps that we are using are the open source versions.
Okay, and what about the specific one with the machine learning? You mentioned PyTorch. Like, is there anything else also? Like, I think there's this MLPerf that a lot of people are now using. Have you heard about that? Have you used that for the Oakridge machines?
Yeah, right now we have actually one of our team members, Junchi Ying, is responsible for running the MLDL micro benchmark suite. And that includes a few of the different common things, but it's mostly like kernels. So one of them is like Deep Bench that they're using for basically running all the different kernels inside there. So they have FFT and things like that, and matrix operations. But we're trying to come up with real workloads because people are using Horobot and Summit and they're solving real science cases. So we're trying to extract some of those because that's when we see interesting, sometimes we find interesting bugs and defects when we're running realistic workloads that the benchmarks cannot catch. But currently all we have is like benchmarks.
Got it. Thank you, Verónica.
Sure.
So next, I think Sreeram, would you like to add a few things here?
Sure. I think so. Typically, when we think of benchmarking, right, like we typically kind of do three tiers of benchmarking, right? Like one is basically we start with micro benchmarks that kind of test say, network performance and performance of data movement within the node. Because like, of course, I'll mostly focus on the communication side of things, right? And so you have performance tests out there that kind of help you iron out the performance of the hardware, right? Say IB perf test, right? And then then you go one level up and you have like library specific tests, right? Like, of course, in HPC, like OSU micro benchmarks for MPI have been kind of the go-to for a long time. But because we are kind of focusing on machine learning and deep learning, like one significant change in kind of system architectures has been from moving away from like single NIC node architectures to nodes that have like many GPUs and many NICs, right? And being able to leverage all of these network cards on the node concurrently is kind of essential for deep learning performance, right? And this is where kind of libraries like Nickel that we develop kind of detect the node topology and kind of leverage these the hardware available in the most efficient way possible. So basing the benchmarks on libraries like this, so nickel perf test is something that we kind of extensively use to kind of evaluate systems in terms of bandwidth and latencies when it comes to machine learning and deep learning workloads. And this is something many of our customers and partners use as well, right? Again, the key is the key distinction is kind of emulating what system characteristics the deep learning or machine learning workloads would stress, right? Which is kind of taking advantage of all of the network hardware available to kind of get the best performance for, say, an already used operation that is executing across the cluster, right? So that's kind of the second level of benchmarking that we do. And then, of course, like Verónica pointed out, we kind of use, how do you say, workload or benchmarks that kind of emulate models and workloads that are kind of out there in the wild, right? And MLPerf is a very good example for that. And one thing we have seen is the set of models that are incorporated into MLPerf is kind of fastly changing from one submission to the other. And they're kind of trying to do their best to kind of keep up to the different applications or models that are kind of coming out there from the different vendors and research labs, right? So I think that's been really dynamic and has been a great example or workload that we kind of use for evaluating our systems. And of course, like Verónica was pointing out that there is effort in the DOE labs to kind of leverage deep learning and machine learning for scientific computing workloads. And one such effort is LBAN from Lawrence Livermore, right? So it'll be interesting to see as these kind of benchmarks make their way into system procurement benchmark suites. Yeah.
Great. Thanks a lot for this perspective. I do have some follow-up, but I think in the interest of time, I would want Jithin to add a little bit here, and then we can probably come back to that. So Jithin, are you with us here? We can't see you, so.
Oh, I am here. Can you hear me?
We can hear you. We can't just see you.
Okay. How about now? I thought I had my video.
I see. We still see at least I see a black screen.
Oh.
Yeah, the same.
Yeah, now
I see.
There you are.
Okay. Yeah. It was using a different camera. That's why. All right. So I had prepared some slides, but I can just quickly go over these. So basically, I was just noting down, these were actually like echoing the same comments that Verónica and Sreeram had made. I'll go in a zoom out and then zoom in manner. So in Azure, we have a variety of specialized compute fleet, right? Like starting from an entry-level VM all the way to specialized AI ML workloads, right? So in this case, I'll just focus on the HPC VMs, the standard HPC, traditional HPC VMs for example, the H series, and then the GPU VMs like the N series. And a good example here is just like like Sreeram mentioned, the NDV4. So it has like 8 GPUs and eight A100 GPUs and 8 200 gigabits per second InfiniBand. So and and around like 6.4 terabyte of memory. So I mean, it is not really. I mean, so in our perspective, like we go a like bottom-up approach. We start from the system. Like I mean, we have these different components like CPU, memory, GPU, network, and storage. I mean, and we focus on each of those separately, but those, I mean, just like the same way that during the AI perf keynote talk, like that doesn't give a full picture, right? So, I mean, apart from the each of the component level benchmarks, like we do end-to-end real application workloads as well. I mean, and on the system, like we start for example, CPU, like we start from like the bare minimal, like MLC, HPL. Then for memory, stream, MLC again, and for GPU, the core performance using the HPL benchmarks again. Network, we go all the way from like basic IB benchmarks to MPI or nickel level benchmark. Make sure like it's getting the same, I mean, the expected performance at node level and also at the full cluster level. Same with storage. And again, like coming back to the end application workloads. So we start with traditional H workloads. Like again, those are domain specific. I mean, for each of those specific queues, there might be targeted for different domains. So we focus on those benchmarks. And the AML workloads specifically, MLPerf, yeah, that is one of the major ones that we use, and also like different training, like RusNet, GPT-2, BERT, all of those we I mean we do. And apart from these, I mean, we do benchmarking exercise with different vendors. For example, NVIDIA, for example, is a great partner. They do a lot of benchmarking on our clusters, and partner teams at Microsoft for the different variety of applications that they will be using Azure clusters, and partner teams outside, like different companies. So it's a multi-dimensional exercise, I would say. And each focusing on like their own end application need.
Sounds great. Thanks, Jithin. So I think if you had some slides and if you had some links and pointers, please feel free to like post them in the chat, sure, and then we can do a follow-up. I think the purpose is that if there are audience, and also probably there are follow-up audience like students attending PPOP, they will get a diverse perspective how things are done in, let's say, Oakridge, and then NVIDIA, and then I think partnership between NVIDIA and Microsoft. So I think we had a pretty broad coverage of what are these benchmarks, but like in the interest of not forgetting them, maybe it's a good idea to have a little bit summary in the chat. So we can sure, do that. Like some of the names you took, I couldn't write them down. Like I think you mentioned MLC or something for the memory.
Yeah. I mean, MLC, the Intel MLC benchmark for the CPU latency and CPU bandwidth ourselves. I'll put the link anyway.
Sure, thank you. So I think I would want to move to the second question. I think Shahzeb, you want to like take that and moderate a little bit.
Sure. Yeah, so the next question that we have is, do we need to develop any new benchmarks for existing or new workloads? And feel free, if any of you want to think about it, can please answer.
I mean, I think the answer is yes. We have our workloads change from system to system, and every year we get new projects. Like the DOE systems are allocated with inside allocations every year. So depending on what projects actually are awarded cycles on the system, some projects are doing like bleeding edge stuff, or they're trying something nobody's tried in the system before. So whenever that happens, we want to make sure we capture that workload. And some people started using Julia on Summit. Like we've never had people that were using Julia before. So now we have to go and find something that we can use to test Julia. So there's many different cases, and particularly with the AI and machine learning codes, like I was sort of mentioning in the beginning, we had users that were interested in it before, but now it's becoming very, very like popular, and it's very much kind of like a core area that people are using Summit for. So we're both trying to identify new benchmarks that we could use, to simulate the workloads that they have. And that's one of the reasons why the ML and data science and data analytics benchmarks were added to the Coral 2 procurement, because we saw that this was actually kind of machine learning. It will take a big chunk of the system in the future. So one of the examples is the Candle project, that it's deep learning for research, which is part of the ACP project. And that's researchers at the lab are involved in that, and they want to use the machine for that project. So we're working with them to come up with things that we can use and simulate their behavior. So in case we upgrade the software, we don't break anything for them, and include them in our list of things to test for.
Thank you very much.
Yeah. Yeah, I'll add to that from a library developer's point of view. Like this saying, like library level benchmarks, like nickel tests, is something that we kind of use for benchmarking on systems. And one thing we have seen is traditionally with HPC, most of the perf evaluation has always like either focused on latency or bandwidth. Like those are the numbers that you kind of see being quoted, right? But with deep learning applications, one thing we have seen increasingly is that, say if you look at the S-curve of the bandwidth, like it's not the left end of the S-curve that matters or the right end, it's actually the middle of the S-curve that matters, in the sense like where your message sizes are in the order of a few megabytes, right? And you have, and one of the things that we kind of observe is that it's not the performance of a single operation that matters, but it's actually a stream of operations, right? Because a lot of these workloads are kind of optimized to kind of to take advantage of all the components in the systems, like CPU, GPUs, and the network, right? So there's kind of a deep pipelining that happens, and also IO, of course. Right, so it's and these somehow have to kind of be reflected in the library level benchmarks we develop to kind of reflect the characteristics of these workloads more. And I think there is work to be done there, and that's where I think more capabilities in the library level benchmarking could help.
Yeah, let me add. Thank you, Sreeram. So can I add a couple more points?
Yeah.
Yep. Yeah, I think like, I mean, my answer was also yes. So, I mean, I think like the data sets are like continuing to grow and be more, becoming more available, and HPC systems are becoming more powerful, right? So, I mean, obviously workloads are continuing to evolve. And to be honest, I mean, I'm not sure if the current benchmarks or work are really capturing all type of workloads. I mean, some of the benchmarks are continuing to evolve, like the AI bench or ML perf, etc. Like it's really evolving. But I mean, even workloads are continuing to evolve. So I mean, there is always this catch-up game. I would think, and so I mean, this is I don't think there will be a lack of need for the new benchmarks. It will continue to evolve, and some of the new benchmarks like AI bench or L bench, for example, are really great examples in this case. Yeah.
Okay, I think because of interest of time, we'll move on to the next question. Thank you. So, Ammar, do you want to take this one?
Yeah, sure. And I think there is also one question in the chat. I see like Jenny's mentioning that, you know, whatever research work we do, we need some classic benchmarks. So the question is, in order to evaluate the performance, power, efficiency of the HPC system, how to choose appropriate and enough benchmarks to do the evaluation? I mean, the diversity of the benchmarks is important here. So I think it's a very broad question, I would say. But like, were any of the panelists would want to take one of that, or like?
Yeah.
Yes. My question is, whatever research work you you do, we need some benchmarks, but maybe you don't know what kind of benchmarks you need to choose. So in this case, so how to help the users or any other software researchers to choose the appropriate benchmark to help them to evaluate their methods, something like that. So because most of the researchers, maybe they are not very familiar with the benchmarks. They don't know how to choose the appropriate benchmarks to evaluate their methods, but choosing the appropriate benchmark is very important for them. Yes, thank you.
I can talk to that a bit. Like I was actually kind of hinting to something similar when I said like improving library level benchmark. So I think one way we could potentially address this is to kind of provide the right knobs in say these library level benchmarks that can kind of be tuned. Like for example, like when I take the example of an already used benchmark, right? It's kind of the sequence of message sizes that are used for already used benchmarks, say in a forward pass or a backward pass, and being able to feed that data into the library level benchmark so that it's more representative of your application workload. Right, I think that would be a useful tool to kind of understand the efficiency of the systems and the software stack as well, and that could be useful for the application developers.
Yeah. Thanks, Sreeram. Yeah, that makes sense. So I think we can revisit this a little bit at the end as well. So our third question that we had in our mind was, how do you sort of make this distinction between what runs in the data center and how it is different from, like, let's say cloud? So I think maybe the typical example of data center would be that you have everything is on premises and there is like no like connection latency and there's no portal or there's no studio. And then you go to the cloud and then you need to like learn quite a few of things to just actually log into your machine and then run something. And then you don't know how is this machine connected to another machine because it's hidden behind layers. So there is like these challenges, right? So I think I want to start with Jithin here and just give us some perspective how and I think you have backgrounds of both because you've been doing benchmarking at OSU on all these HPC systems and then Intel, IBM, and then now at Azure. So how is it different? How is it similar? Yeah.
Sure. So let me start with cloud. At Azure specifically, like we are striving a lot towards like offering, real bare metal like experience especially on the performance, right? So, we have special designs. Like Minroot and CPU groups, etc. Like, we strive to like avoid any of the impacts from the host or any other components impacting the actual workload. So that is one thing, but I would like to go specifically towards the question. So I think one of the prime difference here is repeatability, right? Cloud, that's one of the main concerns that end users have. Like, okay, you run this benchmark once, you may get one performance and second time a different one. So a bunch of factors there, like the set of VMs that you may get at one time may not be the same as the next time. The network connections between those VMs will be different, like especially the network topology will be different. So those are real factors, right? And then storage, that's another important thing. Like, depending on where your storage is, like it can be on a different region, right? So depending on how you configure that can have a big impact. And another important thing to notice here is the shared experience, right? On a typical cluster, what's actually going on the entire system or entire cluster, because so typically you have a job manager, you can see, okay, what are the other things going on, etc. And in this case, like you won't get that complete picture, right? Obviously security concerns, etc. And like even your backend network is actually being shared, right? One of the typical examples is like Sharp. Even though in EDR time frame, the Sharp resources available per NIC or the per switch level was very scarce, right? So I mean, and at Azure, we didn't enable that, right? Because because these resources are scarce, we cannot really, offer repeatability, right? So these are the main differences, I would say. Like, exactly the same things that you noted down, so, I mean, how to overcome these? Like, we are trying to now, we are designing towards, can we have a co-located allocation together? So that can solve much of these and many of these storage things you can explicitly configure. Or you can even move your compute to a different region, like closer to your source of data. Those are the, I would think those are the typical differences and how we alleviate it. And one last thing, repeatability. I think that was one of the even challenges brought down in one of the keynote talks also. So even benchmark level, I think there should be some, the benchmark should really try to monitor the repeatability aspects of the systems as well. So I would think those are specific to cloud.
Great. Thanks a lot, Jithin. Yeah, that's very nicely captured. So Sreeram, Verónica, if you want to add something here, I think data center wise, how are things different a little bit? Let's get some perspective.
I think, the cloud pieces, some of the topics that you touched on, the repeatability piece, it becomes also a problem for us because of the many different things that are running at the same time. But yeah, definitely, if we're able to, if a user needs that are exactly the same performance, they can request a reservation and we can tell them, yeah, you're running exactly in these nodes. And if you see a problem, I can go back and check that specific node. So it's definitely a plus that we have a view of the entire picture, and we can provide potentially reproducible performance if we just dedicate a system for a particular workload. But if you're having everything mixed, you do see sometimes somebody's doing a lot of IO and lost their file system, gets really unhappy and affects everybody else. And you see all these different contentions that maybe you'll be able to isolate better in a cloud environment. That's just one comment.
Cool. Sreeram?
Yeah, no, I think Jithin and Verónica covered all of what was going through my mind, but I'll throw one keyword out, right? Like virtualization. Mm-hmm. I think is kind of a key difference between what you have in like a bare metal data center environment versus a cloud environment. And this kind of happens at different levels, right? You have virtualization within the node in the sense the libraries can't directly detect how the different devices in the server are connected, right, to be able to get the best performance. So there has to be special mechanisms that the libraries use to kind of query this topology of the system. And then Jithin also, there is also virtualization on the network itself, right, which is kind of done for two reasons. Like one is for security, but also for fair sharing. Both of which Jithin touched on, which kind of makes benchmarking really tricky, right? And also the collocation of instances, which is something Jithin touched upon again, right? That is a bit more challenging on the cloud. A bit more is a nice way of putting it. But yeah, it's yeah, those are the things that I think, yeah, they kind of make the lives of both library developers, but also users kind of harder. But I think it also, they're done for a good reason, right? To kind of provide better security and fair sharing of resources in the cloud. And we kind of finding our way through it, right? To kind of get the correct right hooks in to kind of provide the information that is required to get the best performance while ensuring security. And it's a huge challenge.
Yeah, greatly done. Yeah, that's key points, Sreeram. So to be specific, like, the topology, like nickel topology file, like specifying the topology file with that, okay, we can share the topology information, like key point. And again, on network, one thing that I missed to add there is, for example, the new AR or adaptive routing on the IB side. I mean, even though like we have a lot of users using a lot of links, so adaptive routing comes into picture, and then I mean, now the packets can reroute to like through different routes, and then I mean, you won't notice a contention. Like a good example is that I mean, even though most of our networks are undersubscribed, like in one of the cluster, like the upper level thing was still oversubscribed, right? And we could easily see on nickel benchmarks, like when we scale out, like there was a 50% like cutoff, right? With AR being enabled, like that was actually solved, right? So it was completely going back to the close to peak performance. So I mean, these things are evolving, and I mean there are problems, but at the same time, like solutions are also catching up, so to address many of these issues. Yeah.
Great, sounds great. Thank you so much for these very insightful answers. I think Shahzeb, you want to like get the next two questions? I think that's the last two ones we have.
Yeah.
And then we can come back.
Yeah, so the next question, I know we mentioned several benchmarks, but if you had to pick, let's say maybe 3 benchmarks that you want to run for your next system for like acceptance testing, which ones will you pick? And can you please tell me like, why would you pick them? And finally, like if you will like submit your results like officially. So please feel free to just like think about them.
Okay, so I since we only have 3 minutes, I'll try to give a short answer. I'll probably say definitely MPI benchmark, so like something like OSU, because it has a lot of different cases already included. Then I think one that will cover a lot of different aspects that we do run in our acceptance test cases is the spec HPG benchmarks that they also have already cover OpenACC, OpenMP offload, they have MPI. And then the last one that I will pick, I guess that's kind of cheating because the spec has a lot of benchmarks in it, but and then the last one I will pick is one that it's particular for the workload. Like if we're accepting a machine for NOAA program office, we want to run something that they run. And we're accepting for somebody else, we want to pick something that they run and put it into our acceptance test. And as far as submitting results, for anything that it's, we try to publish at least some information from our tests in papers, but for anything that is like submittable, like a spec benchmark, we're happy to publish those numbers and HPL and all the ones that have numbers like Graph 500, Top 500. Yeah.
Thank you. Within your organization, who would actually try to make that decision? Like, you know, some of your team members, would that be you guys? I mean, you guys may have differences of opinion on like what's important. Like, as you mentioned, one, like they want to test workload.
Or
yeah, like within Oakridge, like, you know, maybe one team may want to test, you know, application, but maybe your storage team wants to test IO.
Oh, I mean, we have like, we can't just leave like 3 benchmarks. I mean, in reality, like 3 benchmarks will not be doable, but our group, basically, we form an acceptance teams that like I'm leading acceptance for Frontier, and our acceptance group has like about 23 people. And there's like an SME from like network, IO, applications, machine learning. So we want to make sure we cover as many things. So 3 benchmarks would not be enough, but yeah, it's sort of like we decide by committee once we all get together.
Sounds good. And yeah, and Sreeram and Jithin, would you like to pick for your next system?
Sreeram, do you want to go ahead or?
Sure. No, it's not specifically for the next system. I again, like I was kind of hinting earlier, right? Like I'd pick like one benchmark in each of the 3 tiers I was talking about, like one that kind of shows the raw bandwidth, the raw feeds and speeds of the hardware. The second is a library level benchmark, like all reducer and all to all, that kind of stresses it for the communication pattern. And the third would be the workload that's kind of, and that's where I'd look for Verónica and team to suggest like what would be the application workload that we should run. Right, so yeah, it's kind of, picking one at each of the levels is what I would do.
So you mentioned you already used like nickel for the nickel GPU, but what did you guys do for like the application before you released it?
Applications like I was saying, like MLPerf is definitely one of the main benchmark suites that we use, but that's of course in the deep learning and machine learning space, right? There are different sets of benchmarks that we use for our data analytics, like when there's Spark or Dask workloads. There are different sets of benchmark suites we use, and of course, like Verónica was pointing out, like there are Coral benchmark suites or HPC benchmark suites we use for HPC clusters. Does it answer your question, Shazee?
Yes. Thank you.
Yeah, and yeah, I'm not unmute actually. So yeah, I would consider both the aspects like I was mentioning earlier, like system aspects as well as the workloads. So system, like the different components of the system, like it is really tight to pick three, as Verónica mentioned. Like, but if you are just limited to three, then we need to like focus on the core components, CPU, GPU, the network, and the memory, right? And specifically, like I agree to all of the points Verónica and Sreeram mentioned, but I would like to add. Like network in this case, like especially in cloud, we consider GPCnet like to be really important. Congestion can happen, right? And we want to make sure like that is, that is avoided, and every customer or every user gets the fair share, right? And so GPCnet is a very valuable point. And then other things are really workload specific, like I was mentioning before. All of our SKUs are specifically for like different targeted workloads. We picked that basically based on the end SKU, and I would really emphasize on the storage needs also. And I think the L bench that was really, I think that's a very good example, and it has it is model based on the application needs also, right? So that's. We are not yet using that, but I feel like we should be using those as well.
And I'd like to add, have you guys ever submitted results, or you plan to?
Oh yeah. So for example, Graph 500, like we submitted. Everything on Azure, it's open. Like all the results are open. So last summer, SC20, we published Graph 500. I think around top 17, I guess. Yeah. We publish results, and we even like we post those on our tech community websites or through other forums. We share those results. Yeah. So everything is actually public, all the results. Yeah.
Okay.
I think Emilio has a question, so maybe we can take that.
Yeah. Let's keep that for the right after. So let's go to the last one. So I'd like to maybe kind of understand if you can describe the process that you used for running benchmarks at your data center or the cloud. How do you like evaluate benchmark results between, for instance, runs? I assume you do more than one run. And also, do you keep track of these results, over time? Like, I assume, like, as a system that you get, you may do it at the beginning, but do you do it like after every maintenance or on a scheduled, monthly base? Would you like to elaborate on this, Jithin or Sreeram or Verónica?
Yeah, maybe I can start start with it. So, I mean, my answer was like, it again depends on the workloads. But I mean, a couple of things here is that like on cloud, we really focus on repeatability, right? I mean, so we have like nightly runs, or I mean, like we have canary clusters. I mean, as you may have noticed, like cloud, there are multiple agents, like agents running on the host and agents running on the VM. So, and these things go like changes, right? I mean, so a new version of an agent comes like maybe every other month or something. So I mean, so we have to make sure there are no performance regressions, etc. So we have like separate canary clusters where we run these benchmarking exercises. And and then there are different components also, right? For example, different middleware libraries, say for example, Nickel or different MPA libraries, etc. I mean, those also go through different release processes. So we have to make sure, I mean, maybe some change that is not impacting on an on-prem system, it could impact on a virtualized SKU, right? So we have to catch those also. So in most of our cases, Azure pipelines, they run the benchmarks, like, I mean, maybe at night or like scheduled times, they run benchmarks, and the results are actually pushed to cloud itself. So you can, I mean, historical data are available. So you can go back and those automatically catch any like regressions between different like component versions, or even between different SKUs. You can compare and get the data. So yeah. So yeah, we keep big historical data as well. Yeah.
So how frequent do you run? You said you do it on Azure. Can you just give me an idea? Is it daily or weekly?
So it again depends. For example, like I mean, for example, the agent changes, right? I mean, we know like the release pattern actually happens with like monthly. So at that, I mean, like before or after, immediately after, like we do specific runs to make sure. And then there are other changes also, right? For example, the VM images, like those are like, I mean, the VM image you can deploy to the cluster, and then you have the VM ready, right? So whenever there is a change there, or I mean, there are multitudes of different other agents also. So I mean, typical answer is, I mean, it again depends. Like we have we are focusing on different elements. So based on that frequency, I mean, we initiate those benchmarks, kick off those benchmarks. I don't have a clear answer of like, I mean, what's the actual frequency, but again, like it varies depending on the different change actually. So
yeah, that makes sense. I mean, certainly micro like kernels that go very short, you could probably run them very quickly, but
yeah, exactly.
Veronica, would you like to comment?
Sure, I can give a brief overview. So for we run our benchmarks in both scenarios when we do acceptance testing and when we are going to upgrade a system. And whenever it's possible, we try to run the benchmarks. We put Summit into the new stack, run the benchmarks, put it back the way it was, analyze what happened. And then if it's good, the next time around we upgrade it because we don't want to break things for people. And we do this in a test system too, that is like a one rack of Summit. But and that's where I can actually run more often. But in the actual at scale scenario, I have to get a dedicated reservation, and it's expensive, and you're keeping science from happening. So it's a very limited time that I have to do those regression type tests. It's usually like between 4 to 8 hours at most that I can get before I have to turn the system back over. We do keep historical results just for that reason, so that we know, is it going to be worse than it was before, or who's going to be impacted? Because sometimes we are forced to upgrade regardless because we need the new OS and CUDA and this and that. So, but at least knowing like, okay, in these two cases, you're maybe going to see this problem, helps our users prepared to maybe change something to help that. And how many runs, it depends on how much time I have left. A lot of the times if we're upgrading the file system and Summit, I end up with only like 4 hours. Other times, if they finish very quickly with the upgrade, I can have the whole day. And how many runs? Yeah, I guess that determines for the runs. But during acceptance, most of the acceptance tests, we start with functionality, then we have a dedicated period of performance. It could be a week or so that we run jobs in isolation. And then the stability test where we are doing a workload could have like tens of thousands of jobs in a mixed workload fashion. Usually it's like 2 weeks that it has to be continuously passing. And if you don't get that point, we have to restart. So that can run from like maybe 5,000 jobs to tens of thousands of jobs, depending on how long and what kind of workloads we chose for that particular acceptance.
Are those artificial benchmarks?
It's a mixture of artificial benchmarks and real codes. For stability, we want a majority of real code so that we can simulate a realistic workload.
Right.
Thank you. And yeah, I guess, would you like to add, Sreeram?
No, I think what Jithin and Verónica summarized, like it's pretty typical of what would happen on our end as well, right? Like you were mentioning, Shahzeb, it's there is evaluation that kind of happens on each kind of downtime. Like whenever there is a maintenance window for a data center clusters, there is kind of evaluation that is done at the data center scale for the new software stack that is kind of being deployed. And they do keep historical data to kind of track regressions. But of course, that's kind of the last piece of the puzzle, right? Like Jithin was mentioning, there is a lot of CI/CD that happens for the different components on smaller clusters. So there is already a lot of validation that happens release to release to kind of catch regressions before kind of the stack is put together for deployment. So there is kind of a continuous performance tracking that happens for the libraries or the components, and then there is also evaluation is done at the data center scale as well.
Okay.
Yeah, that's all.
Yeah, that makes sense. Ammar, I'm not sure if you're keeping track. Would you like to see the questions in the chat? I think there was one or two.
I think the one that has been waiting is from Emilio. So he's already here. So we would like to add, like maybe ask this question again so that people are refreshed a little bit. We just have like 3 minutes, so we'll try to keep it short, I guess. Yeah.
So this is related to the comment I made to Verónica, where the importance of having realistic workloads is very important to project and do workload characterizations for capacity planning and stuff like that. So one source of, and I fully agree that sometimes academic environments, I'm in one right now, where it's really expensive to run realistic benchmarks because of the infrastructure that's required. There's an organization that's called Transaction Processing Council, where we used to, back when I was working for an industry, we used to be part of it for transactional benchmarks. They just came out with Internet of Things benchmark, and there's many corporations that compete, and they publish the results. So you have the results there, and the audits and the publications are very open. So it's a good source. More than a question, I guess it's like a recommendation to look into that.
So I guess Jithin, Sreeram, Verónica, have you heard about TPC? Like, have you used it before in any of the? I think I've heard it somewhere at some conference, but I haven't used it myself, at least. Yeah.
So at NVIDIA, like I was mentioning, one like area where a lot of effort is ongoing is for data analytics, right? For big data, for using Spark and Dask. And in that context, the teams at NVIDIA do use TPC, XBB benchmark suite to kind of to track performance of both our software stack and also hardware. So that's one place where TPC benchmarks are heavily used.
Right.
Cool.
And for sure, so I'm pretty sure those are being used in the compute specific or like storage SKUs. I mean, specifically on the HPC SKUs, since they are, the front end NIC is actually 40 Gbps, gigabits per second, and the IB, they range from say 100 to 200, or even like multiple of them. So in the HPC cases, they predominantly go with the IB level benchmarks. But I'm sure those are being used in the compute specific or non-HPC SKUs. I'm pretty sure.
Thank you, Jithin. I think we can probably, I don't know, there's one last question by Kevin that if you want to take. I think we are at the end of the workshop, so maybe the idea is that how much are you relying on simulations when you're preparing for your environments? So do we do that in HPC? I don't know, at least I'm unaware.
For us, we just wait. The vendor does that, and they project the core, what they expect they will get in core benchmarks, and they do a lot of simulation and submit them to us while they're making the system. And once we get the system, we verify that those were correct. And I mean, they verify themselves too before they send it to us. But yeah, we don't do any simulation on our side because the vendor is already doing it.
So Sreeram is the vendor, right?
Yeah, Verónica is absolutely right. For vendors, I think this is kind of essential, primarily for functionality validation, right? Simulation is required to kind of guarantee the hardware works as expected. But again, for performance, it is done to some extent. It's always kind of a work in progress because there is always a delta between the performance you can expect in simulation versus what you see on real hardware. Right. So again, I'm not a hardware person, so I cannot authoritatively comment on it, but it's definitely a key part of our hardware lifecycle.
So the results are going to be as good as your input data. And trace data and data collection is key to get good simulation results.
I agree with that. So I think with that, we are towards the end. I think I would really appreciate, thank you all for joining us for this exciting panel. And at least I learned quite a few new things today. So I'm very happy. I hope the same for the audience. And I don't know, is Kevin or someone around? I think, is that the end? We can just say bye to everyone and